Fourth graders, today is Monday, September 16th, and we are doing Eureka Math Module 1, Lesson 17. Okay, so we're just continuing on. And today, this week, we're doing our final 3 lessons of the week. Okay, there's only 17, 18, and 19. And that brings us to the end of Module 1. Which means that this Thursday, we don't have school on Friday this week. So this Thursday, you're going to be taking your Module 1 test. Okay, so this Thursday, you're going to take a test that will give you the opportunity to show everything that you've learned in Module 1. These 3 days, today, tomorrow, and Wednesday, you can think of it sort of as a review because you have to be able to use everything you've known, everything you've learned in order to solve these word problems. Does that make sense? So it's a chance for you to kind of review and practice all the skills that you've learned. I didn't even say the learning goal. Today, our learning goal is similar to what we were doing at the end of last week. We are going to be using tape diagrams to solve word problems. And the reason why we're spending so much time with tape diagrams is because you're going to find out that this year, every time we talk about word problems, we're going to be using tape diagrams to help visualize or help show using a picture, a math picture, what the word problem is asking. So we're going to get lots of practice so that we become very familiar and confident and skilled with it. So this tape diagram is off to a very good start, but it's a little bit incomplete. It shows that all together, the bakery used 12,674 kilograms. Okay. Then it shows that this part right here was 888 kilograms. So that yellow part, what does that represent? What kind of flour? Everyone? So you might even label it like that. Now I see that there's other sections in this tape diagram. There's this part right here, and there's this part right here. Without any labels, it's hard for me to understand what those sections are. So when you make a tape diagram, make sure you complete it by labeling all the parts. Okay, so this mathematician could improve their tape diagram by writing that this is whole wheat flour. And how much whole wheat flour was there? Well, there was 1,802 kilograms. Okay, and what was left was all-purpose flour, APF, and with a question mark show that that's what we're trying to find. One strategy is I could add up the whole wheat flour and the rice flour to find out how much is not all-purpose flour and take that total and subtract it from my total amount of flour. Yes? What's another strategy? Another strategy is I could take my total amount and take away the whole wheat and then take away the rice flour, and whatever I'm left with is the all-purpose flour. Yes? Good. Today I want to tell you about a new, but it's actually not that new. Once you hear about it, you'll be like, oh, Miss, I already knew this. But let's call it a new because it's the first time I'm talking to you about it. A new strategy that I need you to do every single time you see a word problem. It's called read, draw, or write, RDW. R stands for? Read. D stands for? Draw. W stands for? Write. What that means is every time you see a word problem, the first thing you need to do is read it and understand the problem. And you can show me that you read it, that you read it, and understood the problem by either writing down or underlining what the question's asking, by circling or writing down the important information. And that's your reading step, R. Then you have to D, draw. What do you think you have to draw? Everyone? Tape diagram, very good. Then you write equations and solve the equations, and you write the answer using units. Does that make sense? So it's nothing new, but it just has a fancy new name. RDW stands for read, draw, and write. Let's practice that. Let's do the first step, R. It says Sean's school raised $32,587. Leslie's school raised $18,749. How much more money did Sean's school raise? What's the first thing we need to do? Read. We have to underline what the question's asking. The question is asking, how much more money did Sean's schools raise? Because you don't have the problem in front of you to underline, go ahead and write it down. Then we need the important information. Sean's school raised $32,587. Leslie's school raised $18,749. Now we've done the first step of R. We've read and understood the problem. Our next step is D, draw. We have to draw a tape diagram. Or, in many cases, multiple tape diagrams. Okay? This is a case where we have to draw more than one tape diagram. We can show that Sean, as for Sean's school, raised $32,587. $587. Leslie's school. Did Leslie's school raise more or less than Sean's school? Less. So should that tape diagram, the next tape, be longer or shorter than Sean's tape? Shorter. So let's make a tape that's shorter than Sean's. And we're going to label it. We know her school raised $18,749. If I wanted to make Leslie's tape as long as Sean's, wouldn't this be the difference between the two? So this amount right here is what we're trying to find. Go ahead and label it with a question mark. So in order to find out the difference between Sean's school's amount and Leslie's amount, what operation do we have to do? Subtraction or addition? Subtraction, very good. We've now done the second step. We've drawn a tape diagram. Last but not least, we have to write W. We have to write math equations and solve them in order to write the answer. The math equation in this case would be 32,587 minus 18,749. As I said at the beginning of today's lesson, this is really reviewing a big concept we learned in this module, isn't it? Which was subtracting numbers. So you can see these word problems are really just helping you review what you've learned. Let's go ahead and subtract. I have 7 ones and I want to take away 9 of them. What would I get? -2, but we don't want that. So we have to do what? Regroup. I'm going to take one of these 10s. How many 10s would I have left after I take one away to regroup it? 7. Good. That 110 becomes how many ones? No, that 110 becomes how many ones? 10. But I have 7 already, so how many ones do I have altogether? Good. If I have 17 ones and I want to take away 9 of them, how many do I have left? 8. Good. I have 7 10s and I want to take away 4 of them. How many 10s do I have? How many? Be careful. Good. Okay, I have 5 hundreds and I want to take away 7 of them. That's going to give me -2 again. So what do I need to do again? Regroup. I'm going to take one of the thousands. I'll only have 1 left. Now I have 15 hundreds. If I have 15 hundreds and I take away 7, how many are left? Good. I have 1,000 and I want to take away 8. I need to regroup again, don't I? So instead I have 11 thousands and I want to take away 8. How many do I have left? Okay. I have 2 10,000s and I want to take away 1. How many do I have left? So my number is 13,838. That's only part of my answer. I need to make sure I have the units. Whenever I need to write the units, all I need to do is go back and look at what I underlined or wrote down. Because when I know what the question is, I know what kind of units would answer the question. The question says, how much more money did Sean's school raise? So it's 13,838 money? No. We know that we use, gosh it, dollars. So you can either write the word dollars or you can put a $sign before you box your final answer. Now that we have our tape diagram and we know that this part is B, because container B is this much more than container A, and all together they hold this much water. If I get rid of this extra part, all I'll be left with is 2 A's. So how could I get rid of that extra part? I could do the total, 11,875, and I take away that extra part, 2,391. If I do that, all I'll be left with is this much. Do you guys see that? Do you guys see that? Go ahead and do that math. 5 minus 1 is 4. We need to regroup here. 17 minus 9 is 8. 7 minus 3 is 4. 11 minus 2 is 9. So that means that 2 A's, do you guys see how all I would be left with is 2 A's? So that means 2 A's is worth how much? 9,484. How does that help me find out how much container A holds? If I know 2 container A's can hold this much, how can I find out how much 1 container A holds? Talk to the people at your table group. Finding out that 2 container A's hold 9,484, all we need to do is divide that by 2, which luckily we learned how to do last year in 3rd grade. Yes? Yes? Good. What is 9 divided by 2? 4th graders, what is 9 divided by 2? 4. Very good. When we multiply, what do we have left? 1. We bring down the 4. What's 14 divided by 2? 7. Very good. What's 7 times 2? Everyone, what's 7 times 2? Thank you. What's 14 minus 14? Okay, we bring down the 8. What's 8 divided by 2?
4.
What's 4 times 2?
8.
Okay, what's 8 minus 8?
0.
Good, we bring down the 4. What's 4 divided by 2?
2.
Okay, what's 2 times 2?
4.
What's 4 minus 4?
0.
Good. So we're done. This is a review of something you should have learned in 3rd grade. If this long division is difficult for you, please know that you need to review that. I'm working on the assumption that you know how to do this. So, my final answer is 4,742, but I need to label my answer. Anshul, what's the question asking me? No, the question is not asking me liters. Read in your notebook from step 1, the read part. What is the question asking me?
How much water is in the tank?
Good. And what kind of units are we using to measure water? Everyone? Liters. Good.